So today I got a small repair for you. This is my garage, you might have guessed it already. And the problem is, this was for the lights, basically a relay which activates the lights when the switch is activated and also when the door is opened. And as you can see here, something went a bit wrong there. That's the problem when you do not use the right wire ferrules, I think it is called in English. So the wire was basically loose and that created sparks over time, and then this happened. So, and the way I turn on the lights now is by basically shortening the wires here, if I can get them correctly. And what I will do now is basically solder those wires directly to the perf pad so we don't have the problem like it was before. And yeah, I will show you how I will do that. So this is how I will solder that. Usually I have my electronic soldering iron, which can be powered with a battery, but I thought it would be fun to have something like this. This works with gas. So we basically turn it on. Wait. If I get it. Now. Okay, now it is heating up, as you can see, with the gas. And it gets hot and you can use it as a soldering iron. Pretty cool stuff. And here we got the repaired solution. I know it will not win a beauty contest, but it should be very nicely secured. And if we now go over here, turn the lights on, you can see we got lights. Perfect. Hi there. So in case you're wondering where I sometimes got my video ideas from, it's from daily life actually, because here's an example. I recently switched to an electric toothbrush. Yeah, that's a life event for me. First time I'm doing that, so, and I really like it, but this short clip is not about using an electric toothbrush. It's about how they charge it. And as you can see, there's now direct connection with the charging station and the electric toothbrush. So inside you can see it's lithium ion based, the battery, and yeah, there's no galvanic connection, no copper or anything, but when you plug it in, it lights up and it charges it up. And of course it does that wirelessly, and wirelessly is always kind of an interesting subject I like to look into, and that's why I started playing around what this thing can output. So sadly on the back it says 0.9 watts, which is not a lot, but I just wanted to see how much I can push this charger. And here is just an example with a bit of copper, like this is our coil, and if we place it on here, then you can see, hey, there is some energy that we can get from it. This is right now, you can see it on the oscilloscope. It sends it out in those bursts. I will have to see if that's just for communication or whether it really actually charges like this with those bursts. Maybe there's a reason for that. And if we pause, you can see it's clipped off at the top there because that's where the LED gets powered. And the bottom is a bit higher then, and if we zoom in, we can see it does that with a certain frequency, and that frequency is 47.2 kilohertz. And yeah, I think those are the things that interest me, and that's sometimes how video ideas get started. So yeah, I will see how I will proceed with that information, if it turns into a video or not. I just wanted to show you because I think it is quite cool. Yeah, that's it. So I'm in my garden, and just a quick fun fact. What do you think, how much power does this pump require to pump water from my garden fountain, which is around 3 meters deep, into this small, no matter how it's called, what do you think, how much power? Well, it requires almost a kilowatt, 0.93 kilowatts, so 930 watts of power. That's quite a bit, and also one of the reasons why I will not use a pump like this for my automated watering system. So yeah, just a quick fun fact. So this is what I'm currently working on, the watering system for my greenhouse. Everything is right now wired up. Looks a bit messy. I should probably use more connectors instead of soldering everything, but just tested it, works out perfectly. And right now you can see there is the connection which goes to my water barrel, and there we got the solenoid valve and the water sensor, and then the tap. Not connected to anything. I just want to test it electrically, and currently it is turned on, so I could send a message to the Things network, but I also added a manual button. So if I press that, you can hear it, the valve get activated. You can see it here on the small relay. Turns green. It is turned on, and I'm not sure if you can see that. It's very hard to see, but you can see how the output current basically jumps up to 1.4 amps for quick time. And now I will do the rest of the mechanical setup, and yeah, I hope it will work out just fine how I think it will turn out, and we will see. So yeah, my small watering system for emergency situations or something like that. So here is another small update from the watering system, because I had to show you, it looks so funny. So basically we got the garden hose laid out here, and I'm currently creating the holes in the hose to basically let water escape. And yeah, here you can see how I hooked it all up. Works just fine with the water sensor, and everything goes to my electronics here. And now look at, I didn't expect the pressure actually. Look at what happens when I activate it manually, how far the water goes. It goes to the middle, so I will have to it's quite a bit. I will have to compensate that with more holes, but very promising. I didn't expect, I didn't do calculations like this. Would be very complicated to see with how many holes, then the pressure from the water, which, you know, with the height, and then how far this will go with the diameter of the holes. Super complicated calculation stuff. I'm pretty sure you can do it, but I think the experimental route is just more hands-on for me, and I think for 99% of the people out there. So I will continue drilling holes, and then I will see how the end results will look like. Hi there! So I think I haven't shown this one off in a clip yet. This video is actually already done, filmed, edited, uploaded. Will come out on YouTube soon. And this is basically a continuation of the video in which I try turning an induction motor into a generator, because the comment section said, okay, why not just use a car alternator? And as you might have already guessed, this is a car alternator. Those are the normal ones. You can turn it here. And on the back there are, well, this one is a bit modified, let's say it like this, because you still have to use some current to turn it into a generator basically, but more about that in the video. Very interesting. And as you can see, it is actually hooked up to a bike so that I can turn it. So this gear setup actually creates quite a decent speed. Let me show you. For the alternator, you can power it by simply sitting on the bike and then pedaling here. And yeah, it's really interesting video just to see if you can power your home basically with something like that. And right now I don't need the wood construction anymore, so I'm taking that apart and putting that in my basement. And maybe if the video is well received and people ask for it, I might do a continuation with the alternator, because as I said before, you have to power it with a voltage source to basically turn its rotor into an electromagnet so that voltage and current can be generated. And I just want to see if I can maybe modify that, adding permanent magnets on my own, and maybe optimizing the control circuit in there to get some better results with it. But I don't want to spoil the video, how much power I can create with this. Let me know your thoughts in the comment section. If I should make a continuation, if you already saw the video, or let me know what you think, how much power I was able to output with this thing and this bike setup. So yeah, I'm taking this apart now.